America spends far more on space missions than any other country. However, it's not without reason. Ever since the first objects were launched into space, NASA has completed 25 missions to investigate the Earth's atmosphere, 25 missions to monitor regional climate change, several missions to understand continental drift and gravity, and several missions investigating the water cycle, wildfires, oceans, and the ozone. The list goes on and on. So, was it all worth it? Adjusting for inflation, NASA has spent just shy of $1 trillion solely on space exploration. However, that number seems to be misleading. When NASA commits money to a mission, the money doesn't just disappear. NASA has 17,000 employees as well as 100 plus contract companies which also have employees. In 2018, the US government dedicated $21 billion to NASA's space program, which was about 0.5% of its total federal spending. Now compare that to Social Security and Medicaid, where the US government spent just shy of $2 trillion, or about 48% of its total federal spending. It gets even more crazy when you find out that medical expenses for people with type 2 diabetes were 2.3 times higher than medical spending for people without type 2 diabetes. That means around 70% of $2 trillion, or $1.4 trillion, or 30% of 2018's US federal budget was spent as a result of a completely preventable and completely reversible disease. But no, the government is wasting way too much money on the space program. I know, I sound pretty sarcastic there. It could totally be true that we are spending way too much money on the space program. Maybe in hindsight we'll realize that this whole thing is pretty foolish. But it's my opinion that I don't think you can entirely justify shutting down the space program when you are throwing 30% of the taxpayers' money away to treat preventable, reversible type 2 diabetes. Maybe you think I'm being a dick. Matter in fact, I probably am. But let me describe it in probably more relatable terms. The Apollo missions were probably the greatest things we as a species have ever done. Putting a man on the moon is humanity's great achievement. And all 14 Apollo missions cost us about $135 billion in today's money, or about the same amount of money spent in Vietnam on average per year, every year America fought. Like all things, the moon has a dark side. $135 billion is a lot of money. However, that doesn't mean that all other space operations have to be so expensive. After all, the US government does have a fiduciary responsibility to use the taxpayers' money in the citizens' best interest. In fact, when you break it all down, 75% of the annual space budget is spent on commercial products, such as weather satellites and GPS. Maybe there is science to be learned in space as well. We have learned more about physics in 100 years than we have learned in all of human history, and why should it slow down now? What if we uncover some new physics principle? We could use newly discovered physics properties to possibly make life better here on Earth. Added value, per se. Here's a funny joke. What is an alien with 3 eyes called? An alien. But do aliens really exist? Are we alone in the universe? Well, I'm pretty sure I'm alone in this universe, but that doesn't mean our species is. One day we will almost certainly find aliens. Or maybe they'll find us, or maybe they've already found us. Either way, if we were to prove definitively that aliens exist, then it would probably be in our best interest that we would be an interplanetary species. Maybe only then would we have the mechanisms to join, say, an intergalactic space organization. Of course, statistically speaking, aliens are a certainty, but are we certain that we want to find them? In 1973, MIT radio astronomer John Ball published a paper establishing what is now known as the zoo hypothesis, in which he suggested that the lack of success in uncovering cosmic company might not be because of a lack of aliens, but because these otherworldly sentients have agreed to a hands-off policy, metaphorically keeping their hands off because of our right to pursue our own destiny. If species diversity is something valued in the cosmos just as ethnic diversity is valued among us, maybe aliens believe that life-bearing worlds should be left to their own evolutionary development. When America bought Alaska from Russia, nothing physically changed. However, all the animals that were originally in Russia were now American. They didn't realize anything had changed, but they were now inhabitants of the United States of America. Possibly the same principle can be applied to the Milky Way galaxy. Perhaps a highly advanced alien species has claimed or bought our galaxy using Starbucks, and we don't know. We might be too undeveloped to even be worth telling. Just as bears living in Alaska don't know they're American, we living on Earth might not know that we're living on an alien planet. Of course, how could we be sure that we want to be found? Just as a 10-year-old kicks an anthill for enjoyment, how can we be certain that a hyper-advanced alien species won't annihilate us just because they can? Maybe they want our resources. The Earth does have a tremendous amount of water compared to other planets, and we know that life-bearing planets are few and far between. Maybe a hyper-advanced alien species would cause human extinction not because they need more resources, but because they don't want a possible human threat to their empire. All these possibilities do seem quite unlikely, but they might just be a risk worth taking to possibly speed up our technological innovation. One common argument that I hear against space exploration is that there are bigger problems here on Earth. It's hard to argue with that since the money that would be required to send more men across the galaxy would be immense, and that amount of money would surely aid people on the ground through other means more than it would help being sent on a rocket across the cosmos. Although this may be true, it is also true that some of the most widely used technologies are the direct result of rocket scientists. Space engineers are the reason we have technologies such as scratch-proof glass, which was made for space visors, space blankets which are in almost every first aid kit, CAT scans, and infrared thermometers which can measure your body temperature the same way NASA measures the temperature of stars. NASA was the first to implement LASIK eye surgery, LED lights, electrolytic silver iodizer water purification systems, which is the safest and most widely used water purification system out there, radiant barrier home insulation used in almost all modern housing, the jaws of life, wireless headsets, freeze-dried food, the portable computer, and the computer mouse. Wow, NASA were gamers. When NASA tried to find ways to minimize the size of cameras, they developed the first active pixel sensor, a technology used in every smartphone made today, as well as many cameras. NASA developed a unique material in the 80s that could be used to create flexible circuits used in all computers, phones, and cameras today. Arguments like this remind me of an analogy made by Neil deGrasse Tyson. Imagine you're a caveman that wants to explore what's across the valley and over the hills, but then members of your cave group come to you and say, nope, there's problems in the cave, and you have to fix the cave problems first. You can't go beyond the cave. It doesn't take much thinking to realize just how embarrassingly short-sighted that is. You might have never found that bison herd or that apple tree or that freshwater river if you didn't explore beyond the cave. I think it could be just like that when it comes to Earth and space. We don't know exactly what's out there and what could be revealed to us by space travel. So although it doesn't seem like it, the inventions created to make space travel possible have profound impacts in your life every day. And what I showed you is just scratching the surface. Literally. Scratch the surface of any asteroid and you will likely find silicone and oxygen, which are the two most abundant elements in the crust of the Earth. However, what you will find very little of in the crust of the Earth are rare precious metals such as osmium, rhodium, ruthenium, gold, platinum, selenium, silver, mercury, and so forth. Mainly, and so forth. These elements are crucial for life as we know it, and we are running out of them. According to Physics World, the long-term viability of gallium, hafnium, and indium is in doubt. The American Chemical Society lists 9 elements as facing serious threat to supplies within the next 100 years, the other 6 being arsenic, germanium, gold, helium, tellurium, and zinc. Helium is an interesting one because hydrogen and helium are the only elements light enough to actually escape the gravitational pull of the Earth. In fact, we're almost completely out of hydrogen gas as well, yet we're able to extract it from common H2O. Hydrogen dioxide. Or should it be called dihydrogen monoxide? Technically, H2O should be called dihydrogen monoxide, and the fact that it isn't commonly known as dihydrogen monoxide is a result of a misnomer. However, that is wrong, since every serious chemist of course calls it water. Or they would describe things dissolved in water as an aqueous solution. Talking about things that exist in an aqueous solution, the majority of biomatter exists as cellular creatures floating in the ocean. The ocean takes up 70% of the Earth's surface, and scientists estimate that tiny little plants, bacteria, and algae found in water produce around 70% of the Earth's total oxygen, making aquatic life the most productive fighters of climate change. However, if you want a permanent solution to climate change, it might be in your best interest to go asteroid hunting. Seriously, we need elements like lithium and silver to produce batteries and solar panels, and NASA is already investigating which asteroids contain elements we need. Right now the list is short. However, if space tourism proves profitable, it might prove worth it to mine asteroids and bring back precious ores from space, given you would already be exploring space in the first place. Of course, this would be far into the future. Or would it? Currently, technology is being made by Transastra that would be able to capture and mine asteroids up to 40 meters in diameter before bringing the wanted elements back to low Earth orbit. 300 years ago, it took months to cross the Pacific Ocean. Just 100 years ago, it took weeks to cross the Pacific Ocean. Now it takes hours. This type of exponential increase in speed might not end there. I don't think it's unreasonable to believe that sometime in the future we could be making giant flights to and from the moon or Mars or other planets in just days or weeks as well. One thing is for sure though, a worldwide transition to renewable energy will rely on substantial amounts of metals such as neodymium, tellurium, indium, silver, lithium, copper, tin, and zinc. We will need far more of these elements than we have the ability to mine, and one of the possible solutions is in the heavens above us. What you are watching right now are the plains we left 60,000 years ago when we migrated north into Asia and Europe. In the last 60,000 years we went from hunter-gatherer to space visitors, and I think that's pretty neat. But it isn't difficult to imagine why intelligent life is so unfathomably rare in our visible universe given how absurdly fortunate we have been. On August 12, 1883, Mexican astronomer Jose Bonilla counted a total of 447 UFOs fly across his telescope's field of view over the course of 2 days. The objects were surrounded by a haze and left behind them a trailing mist, a telltale sign of a comet entering our atmosphere. Today, with our knowledge of comets, we think it's likely that this comet broke into more than 3,200 fragments ranging between 500 to 1,000 meters in diameter. For example, the comet that killed the dinosaurs way back when was 10,000 meters across. If just one of these fragments hit Earth, it would have killed millions of people. If many of the fragments did, it would have been an extinction-level event. What's even more amazing is that these fragments flew above Earth just 1,000 kilometers away, about the distance of the average low Earth orbit satellite. My point here is that although extinction-level threats are rare, they are possible, and the only way to ensure the continuation of the human race is to colonize another planet. Only then will humanity be, so to speak, immortal. You might be American or Chinese or Australian or Polish or wherever you're from, but one day we will consider ourselves not by a specific country, but perhaps as an Earthian, among a civilization of interplanetary species. Thank you for watching. Bye everybody.